Stanford University.
All right, guys, welcome to CS 193P Lecture 9. I'm not going to stand up here holding the mic for the rest of the time. We've actually got a great guest lecturer today from Apple, Chris Marcelino. He works on the Springboard. Yeah, it's the app launcher, the home screen, so all your icons when you're launching your apps, and actually does pretty much everything. It's basically, Chris owns the entire phone pretty much, so he can pretty much answer all your questions. So he's going to get up here and talk a bit about core data andplists and XML, basically storing your data and getting it off your disk and off the internet. And a lot of this is going to be pretty relevant to the next part of the paparazzi assignment that's coming up. So there's a little bit of hints in a couple of the slides about some things that you're going to need to know about. The assignment itself goes into a little more detail, and we're going to get into a demo of it on Thursday. So you can get started with some of the table view stuff that we talked about last week. That's a big part of this assignment. So you can get started with that today and tomorrow once we get the assignment posted. And then we'll get into some more specifics with a little bit of a demo. But a lot of that part we're going to kind of leave to you guys to do some reading and get a little bit of the specifics of some of these core data things. We'll give you the base functionality to set up your database with a little class, and you can build on that. So anyway, with that, I'm going to turn you over to Chris, and he'll talk to you about some of this.
So I'm Chris. I work with Josh and Al at Apple. Like Josh mentioned, I work on the iPad and the iPhone software stack and a lot of the SDK pieces. Today, I'm going to talk to you guys all about data on your iPhone apps, which is to say storing data in the iPhone file system to move to and from your app, and also using data over the internet, ways of parsing and reading this kind of data. So we have a bunch of short topics to cover, and I'm going to try to get through as many as I can, but we might run out of time, and of course, you'll have the slides and demos on the internet. But we're basically going to give you the grand tour of the way data is managed on the iPhone. So the first thing we're going to cover is property lists, which are kind of a Cocoa staple for storing simple data. NS user defaults, which is layered on top of property lists, and also, if we have time, settings bundles, which are little ways to add small bits of UI to the settings application on the iPhone that you set NS user defaults. Then we're going to go into the iPhone's file system and sandboxing, as well as object archiving, which is like a more heavyweight version of property lists, and SQLite, JSON, as well as the Apple Push Notification Service, which is an example of one practical application of JSON. So first, let's talk about property lists. They're basically a convenient way to store relatively small amounts of data with very low amount of effort. They can basically only contain the Cocoa types: arrays, dictionaries, strings, numbers, dates, and raw data. That's the NS dictionary, NS array that you may have seen, and NS numbers, but nothing else. You can't go add your own objects or UI views or other types of objects. And they can be stored in two different formats: either XML, which is kind of a human readable, more verbose format, or an internal proprietary binary format, which is a bit faster and a bit smaller. And as I mentioned, the user defaults class is layered on top of this. So you have this easy abstraction to use basically defaults in a simple way. And we'll get to that if there's time. So one thing you don't want to use property lists for, the really big data sets. Like if you have a few hundred megabytes of data, like a bunch of images, you don't want to store those in property lists, because anytime you load a property list, it's entirely loaded into memory. The entire object graph is created. So it's not very good for random access or for lightweight data sets. Your app's going to hang on launch while you load this giant property list. It's not good for complex object graphs. You can't have cycles, and you can't have different types of objects and interesting relationships like that at all. And you can, of course, have custom object types. I'll talk about NS coding and Cocoa's custom object serialization protocol, which lets you do custom object types, but property lists themselves don't allow you to do any of that kind of stuff. And as I mentioned, or I should have mentioned, if anyone has any questions, just feel free to interrupt me at any time. Sure.
So if you're loading this data in the property list, is it available sort of like a global variable?
Well, I'll show you the API in a second. That's a good question. The question was, are you going to have this data available as a global reference when you load a property list? And actually, the API that for loading property lists, which you can see right here, returns an object just locally. So you can reference that object, retain it, release it. It, as you see, returns auto-release objects, but essentially it's free for you to manage. And of course, you'll load it from a file, and you'll end up with this object graph. But one thing before I cover this API I want to mention is you can also do multiple writers easily. With property lists, if you if you have two processes, and of course this isn't that important on the iPhone, but if you have like one process writing and one process reading, you're going to have trouble synchronizing them because there's no built-in like database primitives for managing atomicity and those kind of things. So property lists, again, are just really lightweight data storage for one application. As I was mentioning, the API is a couple of methods on NSArray and NSDictionary, which of course are the containers for these property list types. You can write to files and write to URLs, and similarly, you can init a data or a dictionary or an array with a file or a URL. And of course, whether you pass a file as an NS string, like a Unix path, or a URL, it's totally up to you. In fact, you can actually load property lists over the internet with the URL form, but they're basically equivalent with that exception. And when you create your property list with these initializers, of course, you have an object that comes with a +1 retain count. So you have to release it later, or auto-release it, or keep it around for future use. So does that basically answer your question? OK, cool. So similarly, when you want to write an array, here's an example. You create an array with a couple objects, like a string, a constant string foo, the NS number with bool, yes, which is just the Boolean NS number, and a date. Writing that out using write to file atomically. And of course, atomically, what this does is it lets the operating system write this file at once. It writes it first to a temporary file and then moves it into place without any risk of putting any file that was there previously in an inconsistent state. So if the operating system were to crash or the iPhone run out of battery power, you wouldn't lose any data. You'd either have the data from before or the new data, no bad intermediate state. So atomically, yes, is a useful thing to write when you have data that's important to you. And what you'll get when you write a property list, if you were looking at an XML, would be something like this. You have a standard XML DTD with the property list type, the property list schema, excuse me, and then the three objects, our string foo, the Boolean true, and the date that was 60 seconds from now. This is what the XML form looks like. If you were to write out the binary form, which I'll show you how to choose between in a second, you wouldn't be able to read it as plain text. So it's just something you'd have to encapsulate and trust that it worked. Dictionary is the same idea. You have the keys and values, of course, strings, numbers, data, anything you want. And you write that out, and you get this type of thing. You have a data object with keys and strings, or keys and values for each thing you add in the dictionary. So as I mentioned, you could write out the binary data, the XML data, but those write to data and init from content, or init from path methods don't give you the option to specify what format you want to write in. So there's a class called NSPropertyList Serialization on your iPhones and on your Macs, which lets you pass all those things and get back errors. And this is what those classes look like. So one thing to keep in mind, the error is really useful because if you're writing, say you create an object graph with a few datas and some dictionaries and strings, but you accidentally add like a UI view or one of your own custom objects, you're not going to be able to write that because those objects can't be serialized in a property list. So those write to data files would basically silently fail, or they'd return null. And when you went to initialize it, there would be, of course, no file there. So if you check this function and pass an error string, it will give you back a useful error string describing what you did wrong, which is kind of helpful. You also can specify the NSPropertyList mutability options, which gives you the ability to get back a property list, which is has mutable containers. If you have arrays that you want to get back and be able to modify them without having to copy them, you can just start adding to them when you have the mutability options. The format is either binary or XML, depending on whether you want something that's human readable to some extent, or something that's a little more compact and high performance. So there's a ton of documentation on this, of course. Property lists are pretty straightforward, but if you start using them in your programming, I would definitely check out the documentation and use that to aid you while you're developing. The next bit I want to cover is the iPhone file system, which basically is every application that you write or that you find in the App Store has the ability to write data to the file system, but they can't write outside of their sandbox, their application sandbox. This has upsides and downsides, but definitely more on the upsides. The reasons Apple has sandboxes for their iPhone apps is threefold. First is security. That is, if there's some data on the file system that is used by the operating system, like your private passwords for your mail or those kind of things. The applications can't read them, so third-party applications that weren't as secure or had bugs couldn't proliferate your username and password. There's also privacy reasons. Some of the data, like your calendar data, you may not want being accessible to third-party apps, so the sandbox prevents them from accessing that. But also it makes it really easy to clean up when you uninstall an app, because we know that all that app's data is in one place and can be deleted really simply. So the idea is that every application on the iPhone has its own virtual Unix home directory, just like the home directory you have on your Mac, except there's one for every application, which is kind of a different idea if you've ever used a Unix computer. At the top, there's this application home directory, which is this non-human readable, or it's this human readable hex string that just kind of is a bunch of gibberish inside of a certain path in your iPhone's file system. And that contains your application bundle that you built with Xcode or downloaded on the store. And inside this, you'll see your app binary, which you compiled, as well as any other resources like your nibs and your JPEGs. And then below that, though, is the documents folder, which is kind of the main place you want to put anything your application writes. So if you're saving out images and files, try to put them in that directory. There's a few other directories that are important, like library. And these are often used by system services on your behalf. Like if you want to write temporary files, you can do so in the caches directory. But there's also the preferences directory, which is where the NSUser defaults go, or anything else you want to have. It's kind of more tied to your application as opposed to user data. Caches is useful, by the way, because if you have data that you don't want to get backed up when you sync with iTunes and do a backup, the caches don't get saved off. They're really intended to be a temporary directory, stuff that you don't need permanently, just kind of how you'd imagine like a web browser cache being. So the iPhone OS will enforce that you can only write within this tree of directories, but it won't actually let you write to your application folder. Like myapp.app, if you try to write a file inside there, you'll actually get an access denied, or the property list writing methods will return no, because of code signing, if you were to tamper with your app bundle, your app wouldn't run anymore because it wouldn't have a valid signature. So you basically are forced to write outside the app sandbox. One use of this is that if you have a file, or one idea you need to kind of remember is, if you have a file that you want to modify that comes with your app, you have to first copy it from your app sandbox, your application bundle, to somewhere else in the sandbox, like documents, before you'll be able to modify it. And as I mentioned, everything in here is backed up except for some of the directories like caches and temp. Those are directories that are intentionally omitted, so feel free to write things there that you don't want the user having to wait time while they're backed up. So getting at these directories programmatically is something you need to know how to do. The home directory, which is that top-level UUID random hex path, you can get at via NS home directory. And the temp directory, where you can just write temporary files, which is inside there called /temp, you can access via NS temporary directory. And from there, you can append strings using standard Unix file conventions like / and then some more paths. And NS file manager, which lets you create directories underneath there. There's a couple other easier ways to access them, or at least they're more verbose, but a little more robust. There's something called a function that comes with Macs and iPhones called NS search path for directories and domains. And you basically pass this a series of enum types, and it gives you back an array of directories. And this is useful because if, say you didn't know, for example, that documents was right below your application folder, or your application sandbox path, your home directory, you could ask this function and say, tell me exactly where the documents directory is. And it could find that for you. This is really handy on Macs, because on a Mac, you don't know exactly where your documents folder is. Like it could be, it's inside the user's directory, and you don't know the name of the user's home directory, because that could be in any path. It could be on a network server, it can be under users, and maybe they've moved it somewhere else. So this function, you say, I want the document directory for the user, and this last argument is called expand tilde and path, which basically gives you a real path. But you check the docs, you basically just want to pass yes there. This will give you the exact path to the document directory. And once you get that document's path, you can reference a specific file by saying string by appending path component foo.plist. This is a convenience, by the way, that's basically the same as appending just a / and a foo.plist to the string, except it will make sure there's only exactly one / between documents and foo.plist. So you won't have like 2 slashes or maybe too few. It handles the whole abstraction of separate path components and Unix paths. So as I mentioned, when you want to write to a file that you've created with your, ship with your application, like say you have a big database, it's a starter database, it has all your kind of sample or stock photos, and you want to change that, you want to let the user add and remove stuff to that, you can't change files that ship inside your app's resources. So you first need to use NS File Manager to copy that file into the Documents folder and then modify it from there. Of course, you only want to do that once, because on subsequent launches, you don't want to be overwriting that file every time. So you have to basically check for your file on first launch. And if it's not there, copy it, or maybe use a user default to denote this kind of first launch idea. So as I mentioned, in addition to property lists, we have a more heavyweight solution called object archiving. And this is basically one step up from property lists. We can add custom objects that you write, or maybe the ones that come with the UI kit that you want to serialize into these files. And you can actually do complex object graphs, like cycles and loops. And you can change those object graphs using the advanced features of NS coding, which you can see in the docs. This is how, by the way, nibs work. Anytime you create a nib in Interface Builder, when you save it, it uses these methods to write out a serialized object graph of your views and view controllers in Windows. And of course, unserializes that on your application launch. So this should kind of be a familiar paradigm to you as you use Interface Builder. So the way to make a custom object archivable, like say you wanted to create a object of yours that is able to be saved using NS-keyed archiver, is you conform to the NS coding protocol. It has two required methods that you must implement, encode with coder and init with coder. Encode with coder is what takes your object and turns it into data by giving it your properties to the NS coder. And init with coder is how you create your object from the data to basically reinstantiate it on a subsequent launch. And here's some example ways of implementing it. In every case, you need to call super so that NS object gets instantiated, or initialized in this case. And you can save out all your important properties that you want to persist past the application's lifecycle. In this case, this object has a name, and you're writing that out in the name key, and a number of sides. And then you load those keys and store them as your IVARs again, as your instance variables. It's important that you save all the properties you want that kind of matter to your object, because if you omit them here, when you recreate this object, those properties aren't going to be there. And the keys that you choose here are totally up to you. Anything that you think will be meaningful in future versions of your application. So the keys are arbitrary, just entirely up to you. So to actually use this, once you've implemented this on the objects, or maybe you're using the system objects that already conform to NS coding, you basically take your object graph, whatever you've kind of created, maybe dictionaries of your objects, or maybe just your object and it references other objects, and you say NS-keyed archiver, archive root object to file. And that will give you a Boolean return value to say this worked or it didn't work for a number of reasons. And what that will do is take your whole object graph, call all the NS coding methods, your encode with coder recursively, and write all that to the file. Similarly, to unarchive it, you just do it in reverse. You say NS-keyed unarchiver, unarchive object with file path. And that gives you the root object that you saved out up here, instantiated again by calling all the init with coder methods recursively. And does it kind of make sense how if in your root object you have a property that you say, when you're creating your objects or encoding them, you call encode with coder super, then you call encode object. So you can see how if this object name conformed to NS coding, it would also have encode with coder called in it. So that it would basically work recursively to serialize all this data. And Cocoa will keep all the names and properties separate and kind of handle that recursive state for you. So all you need to do is basically just call encode with object, and as long as the object you're referencing is either a built-in Cocoa type or implements NS coding, you'll basically be able to save a whole object tree automatically and recursively. Does anyone have any questions about this at all? Or am I going too fast or too slow? Just let me know. So of course, as usual, documentation. If you go to write NS coding and you forget what method you need to implement or if something's unclear, I almost always do my coding with my Xcode right beside the documentation web browsers. I kind of need to reference all the specifics of all the functions.
I can see why this is useful for storing the nib data, but I can't think of a case where I would use this.
If the question was, this is obviously useful for writing nibs out, but how would you use this in an iPhone application? And the common ways are if you have your own custom object data, like really simple stuff. You have maybe you write a little music management app and you have a bunch of songs and albums you want to manage, or playlists. You have your own playlist model object inside your iPhone app. And you could implement NS coding on that to make it easy to write out the disk. And of course, if you had your playlists and then your songs, those could be their own objects, and you could just have them all serialized and unserialized automatically for you. So you wouldn't have to go through the effort of turning them into a property list first of just data and strings. So they just let you kind of streamline writing out custom model objects. It's a good question, though. So the next topic in this whirlwind tour is SQLite. And I'm not going to give you a really big demo because we don't actually have enough time to go through all of SQLite, and it's also really well documented on its own. It's an open source project that exists outside of Apple. It implements the complete SQLite, all the SQLite scheme, and it stores entire databases in single files on disk, which makes it really useful for the iPhone. We can basically have all your application data in one small database on the file system. It's super fast because it doesn't handle a lot of concurrency. It's really lightweight and low memory. There's no separate server process like a lot of other databases you might have encountered if you've taken the databases class like Postgres or MySQL. It's free, which is great, and it ships with the iPhone, which is super useful. And it's awesome for embedded devices because of all those reasons, mostly because of its low memory footprint. And as I mentioned, it ships with the iPhone. So there's a few times you definitely don't want to use SQLite, though. If you have really big databases, it's not optimized for that kind of use. It doesn't handle multiple writers very well. Like, it is ACID. If you've ever taken a database class, you've been exposed to the ACID terms that describe, that are the properties of databases. It's not high performance when there are multiple writers. It basically blocks everyone out to make its writes. So if you were trying to do like a big high concurrency desktop application, you might not want to use SQLite. But since that's never the case on the iPhone, of course, it's totally perfect. And it's not great for client-server applications because it's, again, not optimized for multiple writers, and it's all running in one process on your iPhone. So there's a great web page that describes what types of cases you'd want to use that SQLite in. So the big idea for using SQLite is you basically need to open the file, issue SQL statements, and then close it and do something with the data that you've either added or removed. So to open a database, you basically pass a path to a file name, and it hands you back a reference to an SQLite database object. And this is a file name you could have gotten by using those NS home directory methods we talked about earlier to get a path to a file inside your home directory. Maybe you had a database that you copied out from your app bundle to your documents directory. And then you can, you can execute an SQLite statement using this convenience method that basically compiles your queries and runs them for you. You pass it the database that you created when you open the database, and a list of semicolon-separated SQL statements that it will run one at a time in order. And it will give you a callback for every row that the query returns, one at a time. And you can pass it a context, which you get in your callback method. And you can also get back an error if you want. And your callback is the method that's called in every row. And then you close the database to make sure everything is synchronized out to the file system before you exit. So I'm going to give you a quick demo of what SQLite basically looks like. SQLite doesn't actually have, the question was, is there a nice GUI for using SQLite? And that's one of those downsides. There is only, unless you want to go find an open source one, there's nothing provided by SQLite to do automatic database management or object graph encapsulation. So you basically have to create the database by hand, issue SQL statements, create your tables and your columns, and then your indexes, and everything else is up to you. So in short, no, there really isn't.
Can't you add an SQLite file directly on the iPhone? So manage it somewhere outside and then push it on the iPhone somehow. Can you do that?
The question was, can you import SQLite files from the internet? The answer is yeah, sure. If you have, if you get the SQLite file from a website or from some internet source, you can write it to the file system and open it. it's not really a common way of managing data because you're basically going to have to, anytime you pull in a database, assimilate all that data into your own data store and then kind of deal with dishing out to the internet. But if that's totally legal, it's definitely an option. There are probably better solutions that we'll get to in a second, like JSON and RESTful APIs that are more commonly used to access data from databases on the internet. Usually you issue a query and then you get a bit of data back, but we'll cover that in a minute. That's a great question too. So I'm going to show you quickly an app that lets you do the things we talked about. Open the database, issue a really simple query, and do something with this data. So this is the basic template. It has a nib and a single UI table view controller. We're not really using the nib for anything in this example. It's all programmatic. As you see, we create the table view controller here with the plain style. And we set its frame to the application frame and add that as a subview of our window, which came from the nib. And we make that window visible. So this is pretty standard stuff you've probably seen or done. And in the table view controller, in our initializer, we override the UI table view controller's default initializer to call load names from database after initializing our mutable array names, which we're going to add objects to when we do this database search. So we first call load names from database, and then we find the database file path named namesdb. And that's this file you'll see over here on the left I've already created by issuing SQL commands by hand ahead of time that's going to store application data. And this is a database that's inside my resource bundle, my apps bundle, so I don't need to, I can't modify that. But that's OK because the app actually doesn't modify the data. This query right here, we're going to issue select name from person, and that's going to go find all the names from the person table and give us a callback for every row. And you'll see callback here is my callback, and the context is names, which is my NS mutable array. So for every row, it goes and calls my callback and takes the result and creates a NS string with it and adds that to my array. So I'm going to take all the names and populate my array with that on launch. And return SQLite OK. And then, finally, we implement the table view delegate and the table view delegates and data source methods to return the number of names that we've created, as well as a cell for every table view cell, every row that we return back from our query. And that's basically going to give us a really simple toy app like this. And our table view is filled with names of our fellow classmates and president. So I'll show you what the SQLite looks like, how I created that by hand. Let's see. Excuse me. Oops. So this is what. And we'll post all this online so you can kind of get an idea of how these are created. But I didn't do this programmatically. I created this database literally by typing these commands one by one into the SQLite 3 command line tool. And that then gave me that database file as the output, which I put in my app bundle. So often you'll want to create a more dynamic database programmatically in your app. And you can do that by issuing all the SQLite commands. And there's tons of ways of doing it. That SQLite 3 exec command is a wrapper for a wide variety of compiled methods that you can use to create really optimal database searches and sorts. But this is really simple, basic database stuff. If you've ever taken a database class, it should be really familiar. And if not, you kind of can get the idea of what's really going on here.
So I did recognize the SQL syntax there.
Mm-hmm.
Is it the case that there's a process in which you have this SQL syntax and then it creates this names.db separately? And then this is some kind of binary file?
Yeah. So the question was, if I rephrase, what's the process for creating this binary database names.db? And just for the purposes of this demo, I ran a command line tool that comes with SQLite. It's called SQLite 3. And it lets you manipulate databases mostly for debugging purposes and sometimes for development purposes.
And that's already within Xcode, this command?
This command, it's part of all Macs. and you can also download it from the SQLite open source project and build it for any computer. It's just kind of a command line tool that comes with SQLite. You can't run it on the iPhone, obviously, because there's no command line on the iPhone. But the database file is portable. You can move an SQLite database anywhere.
So you have to do this as a separate process as you're building an app. So you can't create like a database on the fly.
The question was, do you have to do this as a separate process? And you don't. Often you're going to create databases on the fly. You're going to actually issue commands to create the data you want. Maybe you get it from the internet, maybe the user inputs it. But you often do create it programmatically using other SQLite C function calls. So this is just for the purposes of this example. I didn't want to really convolute this with writing to the database and entering it in. This basically just reads the database, assuming you already had it in place. Does that answer your question? Cool.
The other interesting thing about this is that, and Chris is going to talk about it in a minute, but core data is a wrapper around SQLite it's been added in iPhone OS 3.0 that provides a much more user-friendly interface to dealing with some of these SQLite databases. So while you still can use SQLite directly, a lot of times now you'll use core data instead, and simplifies things.
Yeah. So the last bit on SQLite, there's a couple references here that are great. SQLite, the project has a great website, so check that out if you plan on using SQLite for anything. But as Josh mentioned, we do have an abstraction over SQLite, which is really useful for for serializing Cocoa objects. It's called Core Data. It's an Apple project. That is, it's not open source and it's not available for any other platform. It's only on iPhones and Macs. And it is basically a very high-level wrapper that makes it really easy to create model objects that you store in your database without having to deal with creating tables, rows, and indexes and all these other things. You use Xcode's GUI to create a description of your object, like all the ivars and properties you create graphically using Xcode. And then you use that and create these objects at runtime, or maybe attach them to a table view to show the values of these objects. And I didn't actually bring any demos for this, and I don't have any slides on it, but I believe Josh is going to talk about this on Thursday because your next project, I believe, involves core data. So it was always on the Mac since about 10.4, I believe, and now it's available on iPhone OS 3.0. And two other things you should know about while we're still talking about core data for your homework assignment that I want to introduce now. One is NSPredicate. And what NSPredicate is, it's this simple class, as described in the documentation, that's used to define logical conditions used to constrain a search either for fetch or for in-memory filtering. Like say you created this object, NSPredicate, by calling predicate with format, which is the way you normally create this object, to say, I want something where the grade property equals 7. And what that does, if you apply this predicate to an array using the NSArray, I believe it's a pry predicate function, it gives you a resulting array with only objects contained whose properties grade value equals 7. So it's basically like a way you can filter lots of objects using a kind of textual, regular expression-like format. So here's a couple other examples. You can follow property key paths. Like if you have a property, an instance variable or a property that has sub-properties, you could use a dot syntax to walk down both properties. And you can also do case-insensitive comparisons where first contains Chris is going to find all objects, match all objects whose property first contains the case-insensitive value Chris somewhere in that string. There's a whole bunch of variations on this. Check out the documentation. It's a giant syntax specific to NSPredicate. Lets you match things, filter on arrays, filter on dictionaries. And it's really key for core data because core data lets you do lots of really kind of complicated searches. And it will handle the searching in the database as opposed to doing it in memory, which is rather useful.
What does like do?
Like, it's defined, it's a good question. So the question was, what does like do? And it does fuzzy matching on strings, but it's worth looking up so I don't get quoted wrong here. There you have it. So it basically lets you do wildcard characters. It's like a reg express match. There's some other options, which I was confusing it with, lets you do like diacritic matching and other kind of extended characters where certain Unicode characters seem like other ones but aren't exactly matching. But if you go to use NSPredicate or core data and you want to do complicated string matching, check out the docs, because this file is just full of things you can issue in your predicate strings to create custom NSPredicate objects. The second class you should know about for your homework is NS Entity Description. It's the class you're going to use to insert an object into a core data manage object context, which is the manage object context is the class, the controller responsible for being the interface between your application logic and your core data database. And this is the function that you need to know to add code, add objects to your manage object context. And again, check out the docs, because you can read all about it. Sorry. So one other thing on the grand tour of data is web services. There are a ton of interfaces and third-party services you can use to access data on the internet. You can do queries against Google servers to access either map data. You can do Twitter lookups. There's all sorts of ways you can harvest data from the internet to either read and write to and from your application. This is kind of the big Web 2.0, revolution. For example, I made a location-based user-generated video blogging mashup for pets. You can basically do any type of data access. There's all sorts of APIs, and tons of websites have RESTful APIs that you can use JSON or XML to get and send data to your application. Oops. So obviously, I'm not going to cover in 5 minutes all the APIs and all the services and ways you can do this using the internet on the iPhone. But a lot of them are exposed via what's called a RESTful interface, which is a way of describing robust web services that are abstracted well enough where there's this really clear separation between the clients and the servers, such that there's no state. Anytime you want to issue a command, you can go ahead and do that. You don't need to have like a connection or build-up logic. It lets you basically query web services and get back the information you need without having to worry about how the information is going to be viewed. Like there's a clear separation between the display of the data and the storage of the data. And that REST stands for representational state transfer. HTTP, by the way, is the kind of classic example of what a RESTful protocol looks like. It's you issue commands like get, put, or and post, and you get back something or maybe an error message. And you don't have to worry about what type of web server is backing it, what software is there, or how it looks, because the web browser defines that. A lot of the APIs used in the iPhone, which are basically just the APIs of the internet proper to access data from the internet, are RESTful. And you can kind of take the data you get back and do whatever you want with it. So quick high-level overview of parsing this kind of data. XML is by far the most popular type of data you get on the internet and used programmatically. It basically was defined to be the first unified standard for computer data interchange across platforms. On the iPhone, we have a built-in library called libxml2, which lets you parse XML trees, either in part or in whole. And it lets you there's two ways of doing it. You either parse the whole tree in memory, or you have this event-driven parser where it gives you one branch recursively at a time. And XML, if you haven't been exposed to it, is basically just a giant tree of objects, of primitive objects conforming to a schema, basically text-based. And you can use libxml, basically pull this data into your application, do whatever you need with it. It's a C API. It's incredibly fast. It doesn't do a lot of unnecessary memory allocation. And you can, of course, link to it and do whatever you want with the data you find that's XML on the internet. We have a Cocoa parser that we created at Apple called NSXML parser. Again, it's also event-driven, which is nice. That is, you get a callback every time a level of recursion is processed inside the XML tree. But it doesn't have all the options of libxml2. It's a little more high-level and simple, but it's pretty useful for a lot of projects. Here's some more references for ways you can use XML and kind of simple first steps in harvesting XML from websites. And we have first we're going to talk about JSON. So the second big modern interchange method for Web 2.0 and 3.0 services is JSON. And it derives from JavaScript. It's a lot like XML, but it's much simpler and more lightweight. When you look at the schema, there's fewer brackets, and it's kind of self-explanatory, a lot like Cocoa property lists, just a few basic data types in a recursive hierarchy. It's easier to parse, lightweight, and a little more space-conscious than XML. And there's a great framework that a third-party developer, a Cocoa developer, put out on the internet called JSON Framework that we use a lot. And I think you're going to be using it in your project if you want to access JSON. It compiles to the iPhone, which is really convenient, and gives you back Cocoa property list types like the NSData, NSString, NSNumber, NSDictionary automatically from the JSON. So that's really convenient. You don't need to create all those property list types by hand. So you definitely check that out. And here's an example of a JSON object. The object at the top level is a dictionary as far as we're concerned in Cocoa. Object is the JSON term for key value store. And here you have a string type matching another string type with a value of Josh Schaefer, students, and then a numerical type, which is just a rational number. There's no quote, so it's not a string. And a third type is the Boolean types, true and false. They're also not quoted, so they're actually special values. And in Cocoa, that would be represented as NSNumber, a number with bool, as opposed to a quoted string. Null is the final type in JSON. We represent that in Cocoa as NSNull, but in JSON, it's just the constant string, the constant value null, not a string. You can also have arrays, which are just the same objects, but arranged inside square brackets, one at a time separated by commas. And then we can close our object using a second bracket. That's a basic JSON object. I'm not sure I mentioned, JSON stands for JavaScript Object Notation. And this is basically how JavaScript looks itself. But JSON is basically taking part of JavaScript and just using the syntax to define an object serialization or a serialization scheme. So it's particularly convenient in JavaScript and very popular on the internet, but it's useful everywhere because it's so lightweight and easy to code. Google has a lot of services, as I mentioned, that vend JSON, so does Yahoo. JSON framework handles converting all these JSON objects, this JSON string data, into Cocoa property list types, so it's easy for you to use them in your app. And for example, you can pull down a bunch of data from Google, and you can take that string and pass it to, pass it to the JSON framework. And get back an object graph. So say the JSON string had a couple keys and values. You get a dictionary back with those keys and values that you could access using object for key. Similarly, you can write one out just like you'd expect it to look. You convert it to a JSON string, which turns your dictionary, your potentially recursive dictionary of objects, into one string, and you can ship that across the internet to your server. And I have a quick demo that demonstrates using the JSON framework to do a Flickr search. So this is another really simple example app. Basically it has a nib, but again, I'm creating a table view programmatically here so you can see how the flow works. It creates a plain table view, assigns that table view to an IVAR, and then creates the table views view as adds the table views view as your subview and makes the window visible. In the table view controller, in the initializer, again, we create a couple IVAR arrays to store stuff in, store our URLs and our names, and then we call load Flickr photos. And what that's going to do is it's going to use a create JSON, a JSON string to send to the Flickr servers. And you'll see here the URL string we're going to issue our query against. See if I can make this wider. Is just like a normal website URL, except we're going to use their REST services and issue our JSON query as a series of key and value arguments inside this URL string. And this is Flickr's public API. You can Google this and read about the couple APIs that Flickr has for accessing data. This is going to return basically as a body of a web page a JSON dictionary, which is going to contain the data that we want to parse and put into our UI. And so we issue that, we create that URL, and we issue that query by calling string with contents of URL encoding. And what this is going to do is NSString is actually going to go out on the internet and get what in effect is a web page, issue that query and get back the data and return it to you as an NSString of JSON. And we're going to call JSON value on that, which is our JSON framework convenience, returning that into an NS dictionary. And I'll show you here that I took the JSON framework source, which you can get on the internet by just Googling for JSON framework, and put it in my iPhone project and just built it. And it built no problem. And then I can import the header here, import json.h, and then start using it to turn that JSON string into a dictionary of results. And we dig through the objects to basically find Flickr defines that their keys of all the photos are going to be under the photos key, and it be a series of an array of photos under the photos key. And for every photo dictionary, they each has a title and a URL for the actual image you can access. So I just parse those out, and this code will be posted on the web. So if you want to see it or derive something from it, you're welcome to. But it basically goes and gets all these photos one at a time from Flickr. This function just adds the names and the URLs to a dictionary, which later we use inside the table view cell row and index path to put the name as the text inside the table view cell, and the URL as an image that we load using NSData, data with contents of URL, and set that image as the cell's image view. So I'll give you an example of how this works, or show you in action how this works. So here's we did a quick a Flickr search for photos with the Stanford tree and got back these photos. And you'll notice one thing: when I scroll here, it's hanging a bit as I scroll up and down this image, and that's because this app is doing these web searches while you're trying to return cells from the table view delegate call. It's like it's doing it on the main thread synchronously, as opposed to kind of doing it without blocking the main UI. So later you'll learn about techniques and what to do and what not to do. But you can imagine that if this were an iPhone and the internet were much slower, like say you didn't have great coverage, your UI would just be sticky. Really, it would be stuck every time you tried to scroll, so it would kind of give a bad user experience. So one thing you kind of pay attention to as you start developing more and more is making sure that you don't block your main thread. But this example doesn't do that, so don't look to this for examples of performance. All right. Oops. So there's also a wealth of information about JSON on the internet. It's extremely popular and very easy to use because there's tons of parsers in basically every language. So, oops. The one big, yes, question.
So in reality, when you do this, would you issue some sort of AJAX call so that it doesn't drop the main thread?
You could. You could do an AJAX call, but you're still going to be doing some type of networking. I think you're going to get more exposure to this. What's that? Apparently you're talking on Thursday about it. But the basic idea, sorry, to repeat the question, excuse me, was do you do AJAX calls, or how do you avoid blocking your main thread, basically? And Josh just mentioned that you're going to talk about this on Thursday, but the idea is you can use background threads or background selectors to kind of issue these queries and then have them call back to your main thread and then change your UI to reflect the new data that was just downloaded. Like you see this in the App Store. As you scroll, the photos appear one at a time in the results of the search. So, but definitely check out next Thursday's lecture. So as mentioned, the Apple Push Notification Service is a big Apple use of JSON. We use JSON to basically route messages through Apple servers to iPhones so third-party developers can kind of make their apps simulate being able to run in the background, since you can't right now keep running your application when you leave your application. So the basic idea is you can show badges on your application's icon. You can display alerts and play sounds at any time whenever the server sends an instruction to the iPhone to do so. And you can do this all without your app running. You don't need a big server infrastructure because you don't need to have every iPhone connected to your server at once listening for instructions. They connect to Apple servers, and then your server sends over a message saying, please, show the badge or show the sound or alert. And their battery life wins in this model where Apple centralizes all of this. It's really important. So the basic idea to do this as a third-party developer is you create your own server. You basically set up a web service that has whatever data is driving your badges and sounds. Like if you have a Twitter app, you'd want to make something that waits for new messages to appear on Twitter feeds and then sends these messages. You get a cert from the Apple website, the developer website, that you need to put on your server to identify your server to Apple. And then, of course, you finally need a provisioning profile to run your app, as you've experienced in creating apps for the device, if you've done that yet. They've done that. Cool. On the iPhone, the workflow for achieving this in your application is you call a method on UI application that says, hey, iPhone, I want my app to listen for push notifications. And that tells the iPhone to ask the Apple push notification server to listen for all notifications for this device and for your application. And then the iPhone OS is going to give back your application a unique token, a series of binary bits that represents this unique iPhone to the rest of the world and to our Apple servers. So then your server can take that token and send you messages with it later. So the second step, the key point is to take this token and send it to your third-party server and do something useful with it there so you can later use it to send messages. And then finally, when you want to send notifications, like say there's a new Twitter message, you synthesize a notification on your server and you send it to Apple with the token that identifies the phone you want to receive, and then Apple routes that all the way through to the phone. And these payloads are JSON, by the way. And then the phone receives it, displays the badge, the sound alert, whatever you actually encoded in this JSON message. I'll show you in a second how to register the service and also how to create these JSON payloads. Oops. So the API to register is UI Application API. You often do this in your application delegate class inside application did finish launching. You call the function register for remote notification types with the types of notifications you want to receive, like sounds and badges or alerts. And that will tell the phone to start listening for these notifications. Then next, you're going to get a delegate callback. You need to implement these two methods, did register for remote notifications and did fail to register for remote notifications. And one of these is going to be called at some point after you register. Once the phone can talk to the Apple servers and get everything squared away, it's going to tell you either, yeah, we connected, everything's great, and here's your device token to hand to your server so you can later send messages, or something's wrong. And the only things that go wrong at the moment are provisioning profile issues. So check it, try again. And this, of course, only happens to developers. They don't happen in the wild. So that token that you got from the first delegate callback, this is what you need to serialize and send to your server to identify this device as a meaningful user of your service. So it's unique to the device. Don't confuse it with UI device identifier because they're actually different. This is, for security reasons, just unique to the Apple Push service. And the real key distinction being the unique device token that you get from UI device doesn't change when you erase your phone, but the push token does, so that if you wipe your phone and sell it to someone, they don't get your push notification messages. Don't bother saving this on disk because maybe the user restores a backup with your app and it has the wrong token in your state. Just call the API and get the token whenever you need. There's a couple more optional delegate methods which let you know when your application was launched from a push notification. But I'll show you what those look like in a second. And this also lets you see what's enabled. So in case your app is like a newsfeed service and you want to know what's wrong, you can see whether the user's turned your app on for notifications and settings. So we talked about you need to send the token to your server so it can send notifications with the token. Your server will connect to Apple services using the cert you got off the Apple website and send a JSON payload to the service, which is forwarded to the iPhone. And these JSON payloads look just like this. There's a top-level dictionary named APS, which is reserved for iPhone UI keys. Outside this dictionary is like your custom app data that will get to your app in a NS dictionary in a COCO format. Inside the APS dictionary, you can say alert and then the text of an alert, which will be displayed in the iPhone. You can set the badge of your application to indicate that you have like unread messages, and you can play a sound on the iPhone that you've bundled with your app when you built the app ahead of time. You can't send sounds across the internet, but you can play ones that are already on your app, like if you had a custom jingle for your instant messaging client, for example. As I mentioned, these payloads are JSON, so they have to be correct and valid JSON, and they're limited in size. And this is what an example alert looks like if you haven't seen one. It's a lot like the SMS alerts on the iPhone. The badges, you can say, I want to change the badge value on the icon. And the sound file's got to be of a supported format or the key default, and we'll handle all the vibration for you automatically. Yeah, alerts also have provisions for localization. Like if you had a message that you wanted to be correct regardless of the current language of the iPhone, you can specify certain keys you can check on the documentation to say, localize this string given a table of correct strings. And question?
If I wanted to increment the badge count, how would I get the current badge count?
So there isn't a way to do that. The question was, if you want to increment the badge count, how do you get the current badge count? Unfortunately, the service won't guarantee that every single message is delivered. It only guarantees that the last message is delivered, so that every message you send then must have the most up-to-date state. Because if this iPhone was offline for like 4 weeks, like you went out of the country or something, we're not going to just queue up, hundreds and hundreds of messages. So make sure the last one says, instead of, John sent you a message, Bob sent you a message, say you have 2 new messages waiting. And so you have to set the absolute truth as a badge value, because you can't be incrementing and decrementing because you might have lost ones along the way. And there's no way to get to the phone if it's offline and ask for the value because your app isn't running. So you kind of have to send the absolute truth in every notification. Removing the white space from the JSON payload really cuts down the size of your payloads. And the JSON parser, the JSON framework that we use on the iPhone, has an option for just omitting white space, basically getting rid of all the new lines and all the spaces. And that usually gets you like a 2-fold savings in space, which is great. So another quick demo on the Flickr app that you just saw, basically augmenting that to receive push notifications. So this is the same app you just looked at with the Flickr table view. The only additions to it are in application did finish launching, we call application register for remote notification types with badge, sound, and alert, because we want to send everything to this phone. And also, on every launch, we're just going to clear our badge number, because you could do something more advanced, like check the number of unread photos or messages, but we're just going to clear it on every launch. We've also implemented the delegate callbacks, did register for remote notification, and did fail to register for remote notification. And anytime you receive one while the app's running, we're just going to reload our photos by calling load Flickr photos and reload data on the table view. So this is a device demo, and since I've already installed it on the iPhone, so I can give you an example of how this looks. But I basically have a toy server I made that let me send notifications to this phone. So here is the iPhone, and I'm going to send it a notification. Give it a sec. So, oops, I didn't have the sound on. Let me try that again. So there you go. It shows a little, I'll show you a screenshot of what that looks like. It's, oops. As you saw in the demo before, you can basically get alerts. And when you slide to unlock, it launches the app, and we show our Flickr photos, just like you saw in the last demo. But yeah, you basically can push alerts and badges and sounds at your server's behest using JSON. Basically about it, because we're out of time. I had a little more in-depth stuff on user defaults you can check out in the lecture slides, but it's a simple toy app that basically uses defaults. Oh, this class goes to 5:30. Yeah. We're going to look at user defaults.
Yeah,
great.
Let me jump in the last 10.
Sure, totally. Yeah. Oh yeah, so I've heard you've been exposed to user defaults before. Maybe one of your example apps or your homework assignments had some user defaults. So I'm going to just kind of cover a few more details about it. As I mentioned earlier in this lecture, it is based on top of property lists. So you can only save those property list types, those simple COCO types, arrays, strings, dictionaries, numbers, and data. It's great for storing settings because you don't have to start choosing your own files and handle all the past stuff. You just basically set a key and a value on the NSUserDefaults class. iPhone OS has a little feature where you can also add settings bundles to add UI to the bottom of the settings app, which sets defaults for your app. And it's all handled automatically if you create a settings bundle for you. So they're key value stores. You say key and you can store a value. The value can be a dictionary or an array, anything you want. But at the top level, you need to specify every defaults value with a key. The singleton name is standard user defaults. Gives you back the object that lets you call object for key, set object, remove object for key, and synchronize, which I'll talk about in a second. And there's tons of convenience methods for getting certain types of objects. Like say you know your setting is a string or maybe it's a number. You can use this convenience method to get that object, and it has the right return type, so you know that you don't have to cast it or do something strange to get it from ID to NS array. And this is also good for safety, for code safety reasons, because if you know your data is an array and maybe an older version of your application returned like a string for it, you won't crash assuming it's an array because it will return nil if the type's wrong, which is kind of convenient. So these are good things to use when you're using user defaults. There's setters for, the setters don't have type checking because you're setting it. You're going to overwrite whatever's there, but they're convenient for the NS number type, so you don't have to box them and unbox them automatically. These are all in the docs, of course. Or just look at the headers when you need to use them. There's one method you haven't seen yet called synchronize. It's called on your application when it exits, but there's times where you'd actually want to make sure all your state is stored to disk. Like say you're running along and the user's going to leave your app open for a long time, and you want to make sure that in case your app crashes, everything's been saved. So you can call synchronize whenever you want to write all the files to disk, the user default files to disk. If you were writing a Mac app on Mac OS X and you knew that another program had written something to your defaults and you wanted to load that in, you can call synchronize to load in other defaults. But that, of course, doesn't happen on the iPhone. And check the docs again. So last demo. This is, again, a really straightforward app that has a app delegate which creates a main view controller. The main view controller has a custom view class with a drawRec method, which will set the color of the main view either red or white, depending on a user default key that I made up called useRedColor. And fill that using UIRecFill. The view controller will call setNeedsDisplay anytime that view is going to reappear. And yeah, I'll show you that bit right now. So when we build this app, this is what we see at first. So we see all white because this default isn't set. The standard user defaults bool for key useRedColor returns no because I don't have this Boolean set in my default, and we set white for that main view. But the other part of this app is, in the flip side view controller, or in the main view controller, when you push the show info button, which is something that I wired up in my nib to match a button. You can't quite see it here because there's a white background, but there's a nib right there called that's attached to the show info action, which gets us to this view controller and its view, which I created in the nib. And if I flip this switch, it calls on the flip side view controller the change colors action, which then we get the color of that switch, or sorry, the status of that switch, whether on or off, as a Boolean, and we set that as the useRedColor Boolean user default and synchronize our defaults to disk, so that when we flip over the flip side view controller, we see red now because drawRec was called, and we drew red over the whole view. So there's one other part of this example app is I created a settings bundle, which you can create in Xcode by choosing File, New File, Resource under iPhone OS, and Settings Bundle. And this adds a file to your applications bundle, which looks like this. And it contains a plist called root plist, whose contents are described in the documentation. I modified the template just a little bit to say, please add a string called redColor enabled that sets useRedColor, and another Boolean default called image alpha that sets the image alpha setting user default to a number between 0 and 1. And that's going to be a slider, a floating point value between 0 and 1. So in settings, what that does is make this settings item appear. And when you go in there, you see our red color switch again, which matches up with what we've set, and a logo color, which we can turn on the Stanford logo, say 3/4 brightness. And then leave, and we go back to our app, we'll see Stanford S right in the middle. So, and the way that works is via view will appear on the main view, takes an image that's in our view hierarchy because it's from the nib, and sets the alpha on it. And that image view you see right here is this instance variable UI image view. So that's basically that demo. The last slide I had for you is just a recap of basically what we looked at, the kind of high-level parts. We had property lists and NSUser defaults. They go hand in hand. We had archived objects, which are like property lists, but let you serialize custom objects using kind of serialization and unserialization code that you write. SQLite is a really elegant solution for a lot of types of problems, especially in the iPhone where we're kind of constrained by space and time. And XML and JSON, which are great for RESTful services and accessing internet resources for your iPhone app. And I showed you the Apple example of the Apple push service. Thanks.
Chris Marcelino, Gordon Eunice, thank you.
Sure.
Okay, so just before we go, I want to show you some information you might want for the assignment 5. Let me hook up here. Particularly with regards to core data. And voila. Okay, so the assignment 5, once again, so you're going to extend on the Flickr application that you did for assignment 4. What we're going to get you to do this time, 3 big things, actually. The first is that you're going to be using UI table view as a way to display the different items in the database. Second of all, you're going to have a database. And the database is going to be based on core data. We're going to give you some helper functions that will help you talk to the database and build some classes that you're going to use to populate your table views. But you're going to need to build the database yourself. So what I want to show you here is just an example of what core data looks like. And the third thing is fairly simple. You've learned everything with regards to this already, is using UI scroll view as a way to zoom in and pan around photos as you go into detail. So let's look first at, I'm going to create a new project that you might want to do this just as an example to see how things work, how things are set up. And I want to show you how the data model is set up. So I'm going to create a new project. And there's a convenient, if you go to navigation-based application, there's a check mark here that says use core data for storage. We're going to go ahead and do that, and we'll call that, untitled's fine. Okay, so this actually, if I just run it, there's no interesting data here. Oh, that's iPad. Let's see. That's okay. Right. Hardware. Device. The little iPhone in the middle. Okay. Sorry. Okay, well, if I run it, you're not going to see anything. You're just going to see an empty table view. And what I really want to show you here is what core data looks like. So there's this convenience called an XC data model that allows you to build your data model visually. It's what Interface Builder is to your views. This is to your model. So this would look familiar to you if you've taken classes on databases. You'll understand how these things fit together. But if we look in the resources area here, and I double-click on the XC data model, you'll notice there are a few different areas here that are interesting. But right in the center, we have one class right now. It's called event. And this event class has a set of attributes and a set of relationships. Right, so if you think of, like if you go back to this would be like your Polygon class in the Polygon assignment. In the Flickr assignment, we're going to ask you to make a person object and a photo object. I'm sorry? Yeah. Oh, I don't know if I can in this view, actually. Yeah, you know what? Let me zoom in. So, all right, so this is the area that we care about right in the middle here. This is one object in our class description. I'm going to go ahead and add another object as an example. So let's just to, I don't want to give away the assignment, so actually I'm not going to rename anything here. But let's add another entity, and we'll call this one, let's say it's, let's just say person. Person. Okay, so what we have now in our core data model are two different classes. And these are, when you're using core data, instead of subclassing off of NSObject, you actually subclass off of NSManaged object. And this is an object that represents something in your database. And again, as Chris and Josh both mentioned, behind the scenes, it's SQLite. You don't have to worry about that implementation. This is kind of all done for you. But I'll show you really quickly how you can add a couple of attributes and relationships. So if I click on the, if I look at our person, and I can add an attribute here, and we're going to call this one name. And you'll notice that the object updates here. And we're going to add a relationship here called, let's say these are meetings. Okay. So now what we have is we have a person object and an event object. The person has a set of meetings he can attend to, and he has a name. Let's add, and now what we're going to do is we're going to tie them together. So if I take a look at this person object, I can actually go to this little information pane over here, and I can specify what the relationship actually means. So this meetings, because I've selected it over here, this meetings relationship will have a destination of event, and you'll see it draws a little arrow. And it's a too-many relationship, so a person can attend more than one meeting. For convenience, we're also going to set up a reverse relationship. So in the event, we'll add a relationship, and we'll call that person, or attendee, or whatever you want it to be. And we'll set that up as the inverse relationship for the meeting. So the meetings, a person object has a relationship called meetings. That's a too-many to the event objects, and a reverse relationship from the event to the person called person. So that is setting up your data model. Now, if we look at the, when I click on the person object, it'll tell you what the class is. And the class is, by default, NSManageObject. This should be fine for this assignment. You can actually change this if you like. You can create a, let's say you had a person class. That's the name of your person object. You can do that as long as you subclass off of NSManageObject instead of NSObject. That should be all you need to know. I would say, use this template as an example if you need to look something up. That's how you set up core data. There's something called a NSFetched results controller. There's more information in the write-up that will help you populate your table views. So, are there any questions about this before we move on? Yeah.
When you fetch, you also fetch an array of the meetings.
Question is, if you fetch a person, does it also fetch an array of meetings? And this is where core data gets to be very convenient, is that it tries to manage that memory for you. Objects are faulted in, it's called. So an object is not brought into memory from disk until it's needed. You can be more specific about that. You can tell core data that I want it to bring those in, but by default, it's not brought in until it's needed. Yeah.
But I still can access it.
Question is, can you still access it if it hasn't been brought in? Yes, you can access it. So, in fact, the act of accessing a faulted object will bring it in from disk. So to you, it will appear as if it wasn't faulted in the first place. So, any other questions? Yeah.
So if we have created already the first project,
Right.
and we have added, let's say, an NS-mutable array between persons and photos in the paparazzi application. So does this work with that, or does it? Or is it going to override it?
Right. So the question is, we've already built these relationships in assignment 1. Will this override it? And the answer is yes. I mean, by building the objects in core data, most of your implementation will go away. And again, you can choose to override some methods if you need to. For this assignment, you don't need to. So I would suggest that for this assignment, you're going to lose your original model implementation. So, any other questions? Okay, well, good luck. Send questions to the class list. We'll see you on Thursday.
For more, please visit us at stanford.edu.